that?
The red.
The red one. We have 3 halves. Which arrow is that? Has to be the white one because the red one was the other one, right? Okay, so now we want to know how much of this is here. How much of this is here? So how much of that red one?
How much of the white one?
Thank you, I knew it wasn't right. How much of the white one is in the red one?
Are we getting these slides?
It's late. I can't give them to you
No,
before
I'm just making sure because I mean, yeah, it's related, because I'll never go.
Let's go to Melissa and then Toby. Toby, what's your, Melissa, what's your answer?
She on the rebuttal.
I have a question.
Oh, okay.
Not a rebuttal, a question.
Yes, a question. So, let's just say hypothetically that you teach keep, change, flip when you're doing division of fractions.
Which I hate.
Hypothetically, yeah. If you were to do that, and that makes sense to the kids, let's just say hypothetically that they get that. And then you show them this. My kids are gonna be lost.
Why would you use keep, change, flip? You might as well teach them the poem if you're gonna do that.
Okay, but I'm trying to figure out how
How do you backtrack, basically? Because they were taught keep, change, flip.
like they've been taught that.
Oh, okay.
And we have to
Except for the few teachers
rewind
that are
that.
here in elementary, that's what they're taught.
Okay, so they've already
So-
been taught either to reciprocate and
So,
multiply.
yeah, so they know
are
keep, change,
taught.
flip.
Or keep, change,
That's what they're
flip.
taught.
So then you would put this up there and you say, how does this fit in to the
Your-
keep, change, flip? Why does the keep, change, flip work?
That's actually hard to
They
do.
have no idea.
That's tough. I mean, that's
No, but
like
that's
higher
what we
level reasoning.
It
for the
will
teachers.
stretch their minds, and it will take you more than one class period
Well, 6
to
weeks.
get this done. Yeah. I hate that keep, change, flip, hang on, because I was in a teacher's classroom and they were using that, and then when they got to multiplication, guess what the kids did? They also had changed and flip on the multiplication, so it made no sense to them, it was just something they memorized, and they didn't get it. Yes, ma'am.
Well, how you just said how to, you put this up there and ask them how it
Would
how
work.
it work. Well, that again, conceptually, I don't even think I remember
Yeah, I
how
don't
it works.
understand how it works.
But I mean, what if you just not do that and start? We're going to learn a new method today, number lines,
Okay,
and go there.
so just ignore your keep,
Yeah.
change, flip, and just show them this.
Another way to look at it.
Because in 5th grade, they have learned
They should
pattern
have
blocks
learned.
and number lines and whatever else.
Maybe.
So they should have some.
Inkling.
Yeah.
Yes, ma'am.
So I see my connection from this of how I would see it is that they're able to quickly identify if it's gonna be greater than 1 or less than 1 by drawing their number line. So they should know, it's kind of like a self-check is, if I get an answer that's gonna be bigger than what I have started with, and my, the way it looks on a number line, it should be their trigger of, oh, I can quickly eliminate, because there's always 2 answers that are bigger,
Right.
and 2 that are smaller.
She's talking about the star example.
Sorry, and
That's
talk about
focus.
the star strategies right here,
Yeah.
because, I already got my brain bit on it. So, I mean, this will be nice just to get that concrete of, hey, are you gonna have a bigger answer or smaller answer, quickly eliminate, and that's something you can teach from the beginning throughout.
Yes, and sketching
So
and
that's how I
underlines,
can
no big
see
deal.
that
Yeah.
helping, but, I mean, the question, how do we erase, and I like the idea of just, we're starting this, but, these are just
There's
strategies.
just
that-
another way to do this.
Yeah.
Yes, ma'am.
Y'all already, okay. Well, we use number talks, the first 5-10 minutes, like just putting up those problems, say less than, more than, those are perfect for,
Number talk.
first 5-10 minutes of class, because then they can use that strategy, like you said, to.
Can I ask you,
so it's
does
like
your
a
school
one-off.
district provide you with a book for number talk? Do you have the Sherry Parish book on number talk?
I've gone to a training, so I know I have it, but I believe, yes, my school last year, Oak Grove had number talks.
Say that again.
We should put that on the list.
Yeah, the Number Talks book by Sherry Parish would be an excellent resource for them.
I'm not sure what the grades are, but I know I have an elementary one now.
The one I have is Pt.3.
I mean, but considering they might start off with
Yeah.
elementary number talks.
It can easily be modified.
No.
All right, are we going on now?
No,
Oh,
I have
yes,
a
ma'am.
question.
Okay, this is a pedagogy question. When I am teaching my pre-service teachers, could we go back a slide?
Yep, if you pay me.
Okay, so when I'm teaching my pre-service teacher, what I would have them do is I would have them come up and to point out the 1, 2, 3. I would have them teach them to have their students do this, or several students do this, you know, so that there's some explanation and not assume that they automatically understand this graphic. So would that be true in math?
Yeah, yeah. You could, I could have, actually.
You were gonna indicate, no, I don't need the pointer. It's actually an insect collection stick.
I have it sometimes, put 3 of the white arrows in here to show, but my method students, they were like, where those come from? So
I
I
just see it's equal, they're like, well, it's the same.
yeah, it was the same, it was the answer they gave.
But
So
you
then
could
I
animate
started
it.
doing that.
You could animate the 3 arrows in there.
Yeah, you could. Yes, ma'am.
Can you go back to the next?
The back or forward?
Forward.
Okay. Yes, ma'am.
So with this one, I mean, the answer is up there, but what would, because your question was how many of, you know, the white arrow fits into the red? How would you?
How much of the red arrow is in the white arrow?
The way you asked it was how much of 3 halves will go into 1 half?
Okay, I'm
So
making
how much
so
of the white arrow, well, you say it that way,
3 halves is the white,
right,
so how much of the white is in the red?
right.
Yes.
Again, since the answer is up there, how would they actually figure out how much of that arrow it is?
The method students,
Mhm.
they have to do what Sandra said, and they realize that that's 3 steps.
Okay, so like, that there's 2, the red arrow takes up 2 lines, so they draw 2 more lines.
Not 2 lines, 2 spaces.
Spaces.
Yeah, because you're counting the spaces in the
And they
number.
find out that that's one of the,
Yeah. So, Jim,
I've shown manipulatives to some of our special ed teachers who wanted to see, you know, how to use them, and I always tell them, and maybe I should have done, is it gonna be less than 1 or greater than 1 first, but I always tell them, you know, if you're starting with a smaller fraction, you're going to have a fraction as an answer. You have to have, well, how do I say this better? How many groups of 3 halves can I make with 1 half? You can't make 1 group,
and that's.
but you can make a fraction of a group.
Yeah, and that's fine, to say it that way is fine.
But, you know, it kind of helps them see, okay, so I'm no longer taking a whole, I'm not making wholes here, I'm making fractions.
Right. Parts of things.
Parts of things.
Parts of things, yes. Which is good for elementary school because they do talk about groups. And when they're multiplying, you have 2 groups of 3, so that's 6. So the kids are kind of into that anyway. Toby?
All right, so the final answer, 1/3. At what level do they know that that's a ratio?
Oh, not until, yeah, 7th grade, 8th
Okay, and
grade.
that's right.
It's moved up, right? It used to be like 5th grade.
They switched them, they gave it, the lower, we were doing 7th into 5th, and we took a 5th grade team
Yeah.
into 7th. I don't know why that intersects.
I don't either.
And exactly what math teaks are ratios found?
7th grade, I believe, is
7,
now.
Yeah.
7, 5?
I think it used to be
7, 5.
6. I don't,
7, 5 or 7, 6?
It
We
used to
never
be
did.
5th and now it's 7th grade?
no, I don't
They
think.
introduced in 6. They introduced in 6 is when it starts, but they took that teak from 5th grade, moved it up to 6th, and then they go into ratios and similarities in 7.
Okay, here's the question.
So it starts at 6.
The science teaks are going to be, quote, streamlined, who knows what that means yet. But there is the question that we've had for years about the density and speed in 6th grade, and 6th grade students not understanding the math.
Depends on when
And
it's.
science teachers teaching tricks and undermining conceptual understanding. So So if it is now at, you said it's introduced at 6 though?
It's introduced in sixth, ratios are introduced in sixth grade. Like the actual word, the form, everything, like it's
So, but they
built
can't
lower.
manipulate the variables?
Nope, not
Okay,
until they
that's what they
teach it.
do in science, they manipulate the variables.
Yeah, they can't
solve
do
for
it until they
unknowns
teach it.
and they don't know how to do
They
it.
don't know how to do that.
And what science, math teaks would that be then?
Solving for unknowns, it does it in sixth too, but they don't know that they're solving for an unknown. It's just an open, what could this be? In seventh grade is when they actually solve for solving for variables in seventh grade teach.
Okay, so what that says in
That's it.
science, that there should
They
not
don't
be the
know.
calculation of density and speed
Until the
in
end of
sixth
seventh
grade.
grade or.
Until they end or mid-seventh grade,
Right.
depending on how their scope is.
It can't be at the end of seventh grade because they don't know, they don't design a scope and, the teaks
That's what I
are
said,
not a
the
scope and
scope.
sequence.
Yeah, so depending on where it's at in scope.
So maybe it should be eighth grade then.
Oh, of course, eighth grade, that would be easy.
Okay,
You're
so
on eighth grade.
you have your pattern blocks out, so we're gonna model this, and here's a big hint, and you have to give your kids a hint. Use one hexagon as one whole to model this and find the answer. 1/2 divided by 2/3. But before we begin, will the answer be more than 1/2 or less than 1/2? Raise your hand if you think it should be more than 1/2. Raise your hand if you think it should be less than 1/2. Okay, raise your hand if you didn't raise your hand. Okay, so when y'all the ones I'm gonna call on when y'all figure out the answer. Okay? So model this using a hexagon as one whole. You don't wanna do this? Probably should.
Yes, you did, I had that question.
So you can divide
Divided into.
How many?
Yeah, it is 2 3 grades and then
And I take that.
so that you can answer that.
So 1 divided by.
Right. So you can't make one.
I don't really remember sometimes.
What I heard you say is for the answer to be more or less than 1/2.
That's right, that's what I want to know.
So it's all trying to model, is if it's more or less than 1.
Try covering this.
Model the process.
Will the answer be more or less than 1/2?
Okay, I see.
So the answer
This doesn't fit in much, that's too much. I don't get how. I get the rules.
How do you okay, so this is the.
multiplication.
So I like what you did. So when you pay,
So if you got my personal
This is a part of the problem. It's like,
so basically what I'm asking, how many times do you have? How many
I get that it's greater, but how do you get one for this? How do you get this to be one of this?
but how do you, oh, and then you break that.
So what do you see covered?
So here's your 1/2, and here's your 2/3. So we want to know.
Don't hate me.
How much of this,
And I did, but I don't know if that's the right answer. So Does that make sense?
It does make sense. So when you say, trying to think of she should ask her to use that one, and I can't use that.
But this helps because it's the same thing. I need this, I need this, and it's huge, but you're, this is what now. Because once I have done this, all of this, then I was gonna have a different like all of them talking about the rules, I don't remember any of those. So everything I'm thinking about is all pictures I put in my Well, I know it's that job, it's so what I know is they're missing that's interesting.
What's your answer, Johnny? Okay, I'll come back to you.
And then I was like, what's your answer? It was 3/4. We worked through it because I was. Jen helped us. Yes, I was very struggling with it. So what I did, I said, what are your time? 4 triangles to the house X.
Well, I had to do it. Because there wasn't a way I'm going to go. So yourself. So I said,
I'm new paper.
Figure out. Let's do it like
Okay. All right, can we come back together in the class? Come back together in the class. So, Johnny, that's not true. Johnny, yes. Ladies, that's the question. Johnny, what is the answer to that problem?
3/4.
3/4. And how did you get that?
Well, Denise helped me. We were on the same track. We were both looking at that shape as a whole.
As a whole, yes.
And so then we knew that was our half.
Yes, the trapezoid.
And so then I knew that this was my 2/3.
Good.
And then I got stuck. And then I wasn't really sure what to do next. And then I heard her over talking. So I looked over and she explained that when she went to this point where I stopped, she later put this little green one.
You mean the green
The
triangle?
green triangles.
Let's use the proper language.
All right, into this one.
Okay, so 3 green triangles is one trapezoid?
Made up that one trapezoid. And then she had to put 4 of the green triangles to make up this 2/3, the 2
Parallelogram.
parallelogram. And then I was able to see it. I was like, okay, now that makes sense. There's 3 here, and there's 4 here. So it's
3 out of the 4.
Yeah.
Which is really a ratio. That whole discussion we just had about ratios, that's really a ratio. We just don't call it a ratio right at this moment. All right, one more. We're gonna use 2 hexagons here as one whole. 2 hexagons as one whole. teachers always tell me that's gonna confuse the students. Not if you do this enough times. They're used to having different holes. They have small pieces, they have big pieces, they're used to having different holes. Okay? 2 hexagons is a hole. You notice it's the same problem, so you should get the same answer. So I'm looking at how you're going to model it. That's one hole.
So back to the hole, okay. So what you need to do is you want to throw there's the same thing between the piece. Now, if I have, so now how is it? So I think you have to go directly to if the center line can demonstrate it, it there's the
So which is larger?
three of those. Three groups. That's what you
Wait a minute, I think that's very, I think she's got it one half. Yeah, well, I'm told her.
So this means one.
So half of them, I think, we want
Comes from high school, so she'll just need, she's understandable.
I get actually, I went through administrative certification. So I terrible. And then my granddaughter, my step-granddaughter, went to go back there.
what she's saying.
I didn't even know that.
But they've taken all the lessons. So they got
You would want to count it.
that's your I don't know what we're gonna do now, so a lot of this year is getting training.
So that's the
So, how much is that?
here's your first one.
And I'm.
That's half of the life. That's your other one, right? 3/3, so now that's 2/3 of a whole. So,
That may be.
1/2 divided by 2/3 is
They're like, but we're not talking about that.
2/3.
Think about all what you're gonna.
So I get your information.
This is still a whole. Right? So that's We have 2/3 of it.
Okay.
Okay, see it? 1/3, 2/3, 3/3.
All right, so,
There's your whole, there's 2 as a whole.
so let's talk through this problem, okay? Y'all ready?
I don't think they're ready yet. We're ready. No.
3 of them.
We got 10 seconds.
Makes sense, yeah.
Gotta get you that triangle.
Okay, we're gonna have to go on, because I do have to leave at 11:30. I don't think she told you why. My nurse today, you know, I have my handicapped child. My nurse today has to leave at 4. I have to be home by 4. The rodeo is going on. So I'm gonna hit that rodeo traffic. The rodeo starts at 4. I don't know if that's where he's going, but anyway. Strange coincidence, isn't it? But I have to be home by 4, so I have to leave at 11:30, so we've got to get through this. So if 2 hexagons is 1 whole, what is 1/2 of your whole? What shape? 1 hexagon. 1 hexagon. What is 2/3 of 1 whole?
4 parallel.
4 of the blue parallelograms. Okay, those tan parallelograms we rarely ever use. So 4 of the blue parallelograms. So we want to know how much of the 4 blue parallelograms is in the 1/2. Is it gonna be 1 whole 2/3 in 1/2? No?
I have a comment. We messed up in the beginning, and we're about to get the opposite answer, like, oh, something happened. And it was finding the 2/3 out of the new whole. So that may be, you know, since we got that, a tripping point for the kiddos to remember, you know, like to set up everything, you know, your whole, and then start taking away. Because we took away, we found our halves, and then we hadn't made our new whole yet, and so we got.
She's absolutely right. Kids need to realize that there are different wholes, which is why I put this problem up here. The hexagon cannot be the 1 whole all the time, because they're just used to that. Just like the green triangle, which happens to be an equilateral triangle, cannot be the only triangles they see all through their K-5 experience. Because then they get to middle school and they have obtuse triangles and scalene triangles, and they're like, that's not really a triangle. Okay? So there are limitations to the manipulatives, and also it is the teacher's job to use different holes to make sure the problem works fine, to use different holes so that the kids are not used to seeing, for instance, just a pizza as the whole, because that's in books all the time. So you have 2 pizzas as the whole, that changes the problem, and sometimes the kids cannot transfer their knowledge over to that because they've not had enough practice. So good point. Good point. So we're not going to do these. We're going to go on to this one because it's in context, okay? And so after I read this, I'm going to walk around and I want to see this modeled. Many of you are reverting back to your teacher knowledge, which, because you're kind of frustrated. I can understand that. But you have got to be able to do this with the pattern blocks, okay? So we're making homecoming mums. And each streamer, you know, those streamers on the mums, uses 1 1/4 yards of ribbon. I want to know how many streamers can be made with 8 yards of ribbon. And this is your whole yard. How many yards do we have, Laura? 8. So how many of these should you model? How many of these one holes? 8 of the one hole, okay? All right, so let's model this problem and get it in. One second. Make a plan here.
So as an administrator, learn to take as you are, is that before, they would take them because one of the things I really like to do is that Brownie just mentioned, you know, touch it is okay. Raise your hand if you think it is. Raise your hand if you think that. How many of you didn't raise your hand? And that's pretty cool. How many of you didn't raise your hand? Because the ones that raised their hand, they're not afraid to raise their hand and say, I don't know, that is awesome. And if you do and teachers authority continues of that whole.
The assistants, because I think it's awesome that it's my son's a second grade. Oh, one and one. Okay, I see what's happening.
So you're replacing. So I'm gonna push you right now.
If you want to be our librarian,
Okay, show me with your fingers how many more minutes you need. 1, 2, or 3? Okay, so I've got 3.
One and one kid goes for how many students?
So now you have.
This is a 4. That way we count. So this is 1 streamer, 2 streamers, 4 streamers, and here's the start. And then I can get two more out and I
So you have it now.
see how
So these are the There's 5. This will be
That is the number one thing that when Dr. Weber asks
but I want time to so these are all where I can have I don't want it to be
So how many
he doesn't see them. And make sure that I need to going to the training.
All right, so let's come back together, please. Let's come back together, please. In the original problem, we had 8 yards of ribbon, and this represents your 8 yards. And you're making a mum, so you need to make some streamers, and each streamer takes 1 1/4 yard. 1 1/4 yard. So, Maura, how many streamers can you make?
6.
6 streamers. Did everyone get 6 streamers? I know you did, because I walked around and watched. Okay? I would not ask that choral response if I had not done that. Maura, did you have a remainder?
Yeah.
What is your remainder?
It's a half of a yard.
Half of a yard remainder. Who else got half of a yard remainder? Okay. What did you get, Pamela?
2/5
2/5 of a,
yard. 2/5 of a whole
of a,
of a month.
streamer. Picking up words. Two-fifths of a streamer. So she said, this group, I heard them talking, and Alexis group, they got 2/5 of a streamer left over, and Maura got 1/2 of a yard left over. So this is on my midterm for my methods teachers, this very problem. They have to sketch it and tell me what you would say as a teacher. So who do I count right? Can they both be right?
Those are the questions. You have to answer the question,
The question is, how many streamers can be made?
which is streamers.
How many streamers can be made?
6.
6. What is that remainder?
Not a streamer.
Yeah,
It's scrap. It goes in the trash.
It makes the little loops that go around.
Is 1/2 yard the same as 2/5 of a streamer?
Yes.
Is 2/5.
The same thing.
Is 1/2 of the yard this the same as 2/5 of a streamer?
Yes, it is.
Okay, Denise is saying yes. How do you know?
Well, because it took 5 of these little pieces to make.
What are those pieces?
Oh, I'm sorry, trapezoid.
5 trapezoids to make
A yard and
make a streamer.
to make a streamer.
Okay.
And if we had one of these left over, that would be one, it would be half a yard because 2 of these hexagons
Yes.
make a whole yard.
You have 1 hexagon left over. So you have 1/2 of a yard.
And that would be the same as 2 parallelograms, which would be 2 trapezoids, sorry, 2 trapezoids, which would be 2/5 of a streamer.
Okay, so how many trapezoids does it take to make a streamer?
5.
5. So you have 2 out of the 5 remainder. So 2/5 of a streamer
Or
or
1/2
1/2 of a yard. Either answer would be correct. Right? Okay, one more.
Oh my God.
We've not done anything with the quiz and error rods yet today, so just do this one with your pattern box. Okay? How many streamers can be made from 4 3/4 yards of white ground? Is it still a hole? It doesn't say. You choose the hole.
You choose the hole? That makes me nervous. I'm doing 4. 2, because this is the only way you can do that. 4. Yeah. Can you figure out another way to do 4 that makes sense? Okay, so. I mean, I haven't used these, but that one is really good. How can we make it? 4 and 3. That one
See, there's one straightforward. Okay, so we have, here's my next recommendation.
I have one.
We have 8 more.
How many? We already have 4 and 3/4.
Yeah, we didn't.
We only got 4 and 3/4.
That's what's gonna happen, because I'm a student.
All right, cut those streamers down.
I never knew anything about moms. I remember the first time I taught in Lockhart. What is the?
All right, starting.
where did you come from?
I was actually born and raised in South America. We moved to the US when I was 12. So we lived in Minnesota.
Where are you
So from Peru to Minnesota. My parents were down in South America. They went down there and we were down there. My sister was a junior in high school.
I'm sorry.
It's great. Very.
They don't even realize.
So she's like talking to these kids who are like, no, I'm just eating. She's like, that's fine.
Well, it's funny too, because even the play, you don't speak Spanish, I'm like, who do you think does this look every day?
And I'm going
It's changed a lot.
I didn't know.
If I can have your attention again, thank you, Melissa. Okay, so we're working the same type of problem. Again, we have, well, this time we have, how much? We have 4 3/4 yards of ribbon. I did not tell you what to use for your hole. So you would have to know by this time that you needed a hole that would work with fourths. So I noticed that most of y'all stayed with the 2 hexagons as your hole, because the trapezoids then would be 1/4. So it works nicely that way. If you allow, of course, if you allow your students to figure out their own hole after they've had more than one problem, you know, because y'all are teachers, so I know y'all can go faster, then you really get some insight into their thinking. And that's important, so you know misconceptions that you can clarify. So there's a difference in a mistake and a misconception, okay? What's the difference in a mistake and a misconception? Jen?
So a mistake can sometimes be procedural, forgot to carry my one. A misconception is, I have a complete wrong idea about this.
Exactly. So a mistake is just something that they accidentally do wrong, so they didn't regroup their one. And then a misconception is they don't know how to work the problem. So they worked it completely wrong. For instance, the keep, change, flip they did with multiplication, not division. That's a misconception. Which one is harder to clarify? Misconceptions, they take forever to clarify, but mistakes are fairly easy. You know, all you have to say is, how did you get this? And they will notice usually their mistake, okay? So most of you use the 2 hexagons for your one hole. So how many streamers can be made? Lisa? 6. Raise your hand if you got 6. Everybody, good, and I knew that already because I walked around. Is there a remainder?
Yes.
What is the remainder, Lisa?
It could be 1/3 of a streamer or 1/4 of your yard.
Okay, so 1/4 of the yard,
If you, yes. If
a
your yard was-
trapezoid, if this is your hole,
Yes.
or how much of a streamer?
1/3 of a streamer.
1/3 of a streamer. How many of you got those 2 answers for your remainder? Good, okay. We've not used the Cuisenaire rods, but we have a little bit of time now. So I want y'all to use the Cuisenaire rods. We're not going to do the number line. Cuisenaire rods to work this problem. Oh, no.
too.